Rank the following from least reactive to most reactive towards nucleophilic attack. So if we look at these three compounds that we have, these are all carboxylic acids. So if we look at the first one, we have an ester. If we look at the second one, we see that we've replaced the OH with a nitrogen group, so this is an amide. And finally, the last one, you replace the OH with a chlorine, so this is an acid chloride, also known as an acyl chloride. Okay, and so now that we've identified these as carboxylic acid derivatives, we know that they're going to undergo nucleophilic acyl substitution reactions. So carboxylic acid derivatives, let's make a note of this. So they undergo nucleophilic acyl substitution. So this is the reaction that we undergo. So it means that you're going to replace a leaving group on that carbonyl carbon with a nucleophile. That's what nucleophilic acyl substitution means. And so the least reactive would be the one with the worst leaving group, because if you want to replace it in a substitution reaction, if you think back to SN1 and SN2, you needed a good leaving group. So least reactive would have the worst leaving group, and so the most reactive would have the best leaving group. So we want to recall back from substitution and elimination chemistry, well, what makes a good leaving group? So good leaving groups are going to be either very weak bases or neutral molecules. So if we want to compare these in terms of reactivity, we want to look at what would be kicked out as a leaving group. So if you're looking at an ester, you're looking at this alkoxide as the leaving group. Right? If you're looking at this amide, you're looking at the NH2 minus as being the leaving group. And if you're looking at the acid chloride, then you're looking at chloride as the leaving group. So this is your best leaving group for sure. So this is going to be the most reactive. And then we know that because chlorine is the conjugate base of hydrochloric acid, which is a strong acid. So it is a really weak base, right? And then if we're going to compare this NH2 minus to the alkoxide, we're comparing a negative charge on a nitrogen versus a negative charge on an oxygen. And those are in the same row of the periodic table. So a negative charge on that more electronegative oxygen is going to be more stable. So that means that this is going to be our worst leaving group. So this is going to be the least reactive. So if we're going in order from least reactive to most reactive, that means we're starting with this amide, and we're saying this is more reactive than the ester, which is more reactive than the acid chloride. So we are looking at the first option here.